All right, so in this video, we want to find the equation of a linear function, an exponential function, and a log function that passes through these 2 points over here. So let's start with the linear function. We know that the equation of a linear function is just y equals mx plus b. Then we're going to sub in and find our slope by using y2 minus y1 over x2 minus x1. The slope is -3 minus 2 over 10 minus 5, which is -5 over +5, which is just -1. I'm going to rewrite my equation here with a slope of -1, y equals to -x plus b. And then we want to find our y-intercept by subbing in any one of these 2 points. I'll just sub in the first one here. So 2 equals to -5 plus b. Move the -5 to the other side, it adds. So I have 7 equals to b. So my linear equation over here is y equals to -x plus 7. Next, let's find the exponential equation that passes through these 2 points over here. So for an exponential equation, you want to sketch it out first so that it gets a bit easier to find the equation. We have 5 and 2 over here. And then we have 10 and -3 over here. So if I'm drawing an exponential function, there's a couple of ways you could do an exponential function for this. I could draw an exponential function like that, or I could also draw one going, I guess, like that as well. I'm just going to do it like this over here. I'm going to keep my exponential function like this. This point is 10 comma -3. This point is 5 comma 2. And I'm going to create my horizontal asymptote. We have to always create a horizontal asymptote if we're not given one in this question. So I'm going to create a horizontal asymptote right there. And I'm going to make that y equals to -4. So I've just selected one value below -3 for this one. You could also select -5, -6, doesn't really matter. I'm just going to pick -4 for this one. So an exponential function is y equals to a b to the power of k times x plus c, where k is either positive or -1, depending on if there's a reflection in the y-axis. And in this case, as we notice, if we're doing exponential growth would go that way to the top, which means we do have a reflection in the y-axis here, which means k is -1. You don't have to worry about horizontal shifts. You don't have to worry about the k value being anything else. So I know that for this one, my k value is -1. So y equals to a b to the power of -x. And I also know that my c value is just my horizontal asymptote, which is -4. Then I want to sub in my points and solve for a and b. So I'll start with subbing in this point over here. -3 equals to a b to the power of -10 minus 4. I will move this 4 to this side and add it. So 1 equals to a b to the power of -10. I can't really solve this equation anymore over here because I have two variables. So I have to just sub in my second point into this equation here. So 2 equals to a b to the power of -5 minus 4. And And then I'll just add the 4 on this side. So 6 equals to a b to the power of negative 5. Now I have two equations and I have two variables. So I have to solve this with substitution. To make things a bit easier, I'm going to start by just making my exponents positive for both equations. So here 1 equals to a over b10. And over here 6 equals to a over b5. I can actually isolate my a for both equations. Honestly, I'm just going to cross multiply these across. So b to the power of 10 equals to a over here. And over here, 6b to the power of 5 equals to a. Now I've isolated a in both cases. I can just do substitution. So b to the power of 10 equals, I'm going to replace this a with 6b to the power of 5. And I'm going to divide both sides by b to the power of 5. So I get b to the power of 5 equals to 6. And then I get b equals to the 5th root of 6. Come back here and sub in my b over here with the 5th root of 6 to find my a. So 6 times the 5th root of 6 to the power of 5 equals to a. The 5th root of 6 to the power of 5 is just 6. So 6 times 6 equals to a, which means 36 equals to a, which means I can write my equation as y equals to 36, 5th root of 6 to the power of negative x minus 4. And this would be the equation of my exponential function that passes through those 2 points. Now, third and final, let's do the log function that passes through these 2 points over here. 5, 2 and 10, negative 3. So again, we'll start with a sketch for a log function because exponentials and logs a lot harder than linear. You want to sketch it out. So 5 and 2, then 10 and negative 3. So log functions, remember log functions have vertical asymptotes. So I could do a log function that looks like this basically. And this log function has a vertical asymptote over here. Now remember, there are multiple solutions for this question. You don't have to get the same answer as me. I'm just doing one like this, because I find this is going to be the easiest for a log function. And what I want to do here is I want to label my asymptote. I'm going to pick one value less than 5 for my asymptote. I'm just going to pick positive 4, but you could pick 3, 2, 1. You could pick a lot of different numbers. It doesn't matter. The solution will change slightly, but the steps are the same. I just like to pick the closest x value because that's the easiest generally to calculate. Now, a regular log equation looks like that. So we know this one has a reflection in the x-axis, but we don't have to worry about that because when calculating our a, it will automatically take care of that. This log function has no reflection in the y-axis, so I don't have to worry about a k value. My k is positive 1, which means that my equation is going to be y equals to a log b x minus d plus c. I don't need to worry about a k value because I've already established it's positive 1 over here. The first thing I'm going to do is I'm going to look at the gap between my asymptote and my first point. So the gap between these two is 1. And then I'm going to compare with the gap between these two. So from 4 to 10, the gap is 6. So 6 divided by 1, you're just dividing the second gap divided by the first gap. 6 divided by 1 is just 6. So the base of this function is just going to be 6. The d value is just the vertical asymptote, which is basically shifted 4 units to the right. So it's x minus 4 plus c. So I've established my b and d value. I just need to find my a value and my c value next. In order to do that, I just need to sub in my points. I'll always start with the first point. So 2 equals to a log 6, 5 minus 4 plus c. 2 equals to a log 6, 1 plus c. Log of 1 is 0. 0 times a is 0. So 2 equals to c. So you can also remember that your first point, the y value, is generally the c value as well. You don't have to do all the steps like I did over here, but I like doing all the steps. I can rewrite my equation as y equals to a log x minus 4 plus 2. Then I'm just going to sub in the second point here to find my a value. So negative 3 equals to a log 6, 10 minus 4 plus 2. Negative 3 equals to a log 6, 6 plus 2. Negative 3 equals log 6, 6 is 1. 1 times a is just a. And if I subtract this on the other side, negative 5 equals to a. So my log equation for this question would be y equals to negative 5 log base 6 x minus 4 plus 2. Now, there are multiple possible solutions here. You could have always done this in another way, but this is one of the possible solutions, the easiest one for me to find. And as you can see in this video, I've showed you how to find a linear, exponential, and log equation given 2 points.